Solve one problem on turning moment diagram of three crank engine when driving torque is variable and load torque is also variable. Given question, the torque developed by three crank engine is given by TE is equal to 19,000 plus 7,000 sin 3 theta Newton meter, and the torque requirement of machine is TO 19,000 plus 3,000 sin theta Newton meter. Calculate maximum fluctuation of energy in the flywheel.
Let us understand how to draw turning moment diagram for a given driving torque as well as load torque. So if we observe the equation, TE is equal to 19,000 plus 7,000 sin 3 theta. So this torque is in the form of theta, so we can say that this driving torque is variable. Now if we move to the load torque, then TO 19,000 plus 3,000 sin theta. So this equation is also in the sine form. That means this load torque is also variable. Now how to draw this turning moment diagram. So on the horizontal line we will plot here the theta, that is the crank angle in degrees. So we will take some suitable scale. So I will take here this scale, that is for 45 degree I will take here 4.5 centimeter. For 90 degree I will take distance 9 centimeter. For 135 degree I will take here distance 13.5 centimeter. So we have to take these angles at some equal interval, that is I have taken here 0 to 45, 45 plus 45 90, 90 plus 45 135, 135 plus 45 180, and so on. So we have to plot all these angles. Now on vertical line we have to choose some scale. So if we calculate these different values of torque by putting all these angles, then here are the values. So these values varies in between 12,000 to 26,000. So with some suitable scale we have to plot these points. So if we observe, I have taken here the minimum value 12,000, and after that by taking some suitable scale, that is 1 centimeter or 2 centimeter, next will be for 14,000, and next 16,000, then 18,000, 20,000, 22,000, 24,000, 26,000, and so on. So we have to plot in between this minimum and maximum value. So for that we have to calculate the value of this torque by applying all these angles. So the same method is to be applied for this load torque. So for the load torque, the value of TO varies in between, that is which is the minimum value, that is 16,000, and which is the maximum value. So if we observe, maximum is 22,000. So we have to plot these values on this torque in Newton meter, and on horizontal line same angles we have to plot, and by taking the same scale. So this scale should be same for this driving torque also and for the load torque also. So what is the reason behind that? So reason behind that, we have to superimpose these two diagrams. So after drawing this torque turning moment diagram for this driving torque as well as load torque, we have to again superimpose these two diagrams. So for that we have to take same scale for these two diagrams. Now I will take the angle 0 degree. So when we put theta is equal to 0, then TE is equal to 19,000, and for load torque also TO is equal to 19,000. Now with the help of calculator we have to make these calculations. So here we will select the point for 19,000. So it is in between 18,000 and 20,000, that is the middle point. So here also in between 18,000 and 20,000 middle point we have to select. Then we will take one extra angle, that is 30 degree. So if we plot here 30, that is 3 into 30, sine of 90 multiplied by 7,000 plus 90,000, that is 26,000. So here is at 3 centimeter distance we will take here 30 degree angle, and we will plot here 26,000 value. Now in the same way for TO, this value is 20,500. So here is 20,000, and after that there is 20,500. So we will select here one point, that is at 20,500. So we have to join this point. So we will join this. So here also we have to join. Now we will move to the next, that is for 45 degrees. So when we put theta is equal to 45, then TE 23,950. So where is 23,950? So it is nearly equal to 24,000. So here at 45 degree we will select here one point nearly equal to 45 degree. And here also now for TO, if we put here theta is equal to 45, then TO is 21,121. So 21,000, that is, it is slightly above than this 20,000. So we have to select here one point that is slightly above this 20,000. So we will join this. So here also we will join this. Then in the same way at 90 degree. So at 90 degree it is 12,000 and here is 22,000. So we will select here at 90 degree it is 12,000. And here 22,000. So 22,000 is here. That is, it is above 20,000. So here is 20 and here is 22. That means we have to select this point. Now we will join this. And here we will join this. Now next for 135 it is 23,950. So 23,950, that means approximately equal to 24. So it is at 135. So for 135 we will select here one point and then we will join this. And then for 135, 21, 121. So here at 135, 21, 20 is here and 21 is here. So at 135 we will select this point and we will join this. Then next for 180 it is 19,000 and 19,000. So both are 19,000. So here in the similar way, that is at 180 degree we will select this point and now we will join this. And here also it is 19,000. Now next is 225, it is 14,050. So it is nearly equal to 14,000. So here is the point for 14,000, that is in between 12,000 and 16,000. So for this angle of 225 we will select this point and we will join this. And here also 16,878. So 16,000, it is above 16,000, that is approximately equal to 17,000. So here if I select this point here, so we have to join this point. Then we will move 270, it is 26,000. So for 270 it is 26, that is the highest point. So we will join this highest point. Then next it is 16,000. So 16,000 is here. It is in this line. We will join this. Then next is 315. It is 14,050. So 14,000, that means it is in between this 12,000 and 16,000. So we will again join this point. And for it is 16,878, that is approximately equal to 17,000. So again here 16,000 and after that it is 17,000. So we will mark here one point, that is for 315, and we will join this. And then 360, it is 19,000 and 19,000. So 19,000 is here. That is as the starting point, here the end point is same. So as the starting point, the end point is also same. So this is the turning moment diagram. So this is the turning moment diagram for the driving torque, that is TE. So we will show here this turning moment diagram. I will show with different color marker. That is, this is the turning moment diagram for TE and this is the turning moment diagram for TO. Now we have to superimpose these two diagrams. So if we observe, we have to select the same values. So because the scale is also same for both the diagrams, for this torque as well as theta, it is easy for us. We will superimpose this TO in this diagram and then we have to find out the point of intersection. So now if we observe, so I will join these points. So again, for 0 degree it is 19,000, that is the same point. For 30 degree it is 2500. So here is 20 and then it is 500. That means we have to show here at 30 degree slightly greater than 2500. Then it is at 45 degree 121. So it is above 20, that is at 45 degree. We will show here it is approximately equal to 21,000, that is the middle point in between 20 and 22. So I will select this point and we will join these. Now we have to join the same way at 45 degree, then 90 degree it is 22,000. So at 90 degree it is again 22,000, that is in between 20 and 24. Here is the point. So we have to take the scale and we will join this. Then again 135 is 121. So here 121 at 135. So if we take here is 20 and here is 21, that I will join these 2 points. Then next, after this 135 it is 180 and 180 it is 19,000. So 19,000 is the point that we have selected earlier here for this 180. So here the points is same. So we will join this curve. Then again for 225 it is 16,878. So 225 it is 16,878, that is approximately 70. So we will select here 1 point and we will join this. Then it is 270, it is 16,000. So 16,000 is here. So for 270 we have to join this. And then 315, 16,878. So for 315 also it is again 16,8, that is approximately equal to 17. So here we have to join this point. And then 360 it is again 19,000. So 19,000, if we observe, here is also the same value, that is 19,000. So we have to join this. So this is the superimposing diagram. Now how to find out the maximum fluctuation? So if we observe, we have to first select the area. So I will select the areas for this shape, that is this area we will select here. Now what is happening within this area? Because this is the load torque TO, I have shown with the help of red marker. Now in this case, during the first this 45 degree, or I will say here is the point of intersection at this point. Now I will select here this line. Now up to this degrees of crank angle, what is happening? Flywheel is gaining the energy and its speed increases. Now for the next point of intersection is here. So I will show here. Now during this crank angle theta, it is before 135, here the flywheel speed is getting decreased because it releases energy to the load machine. So here I will show the area. So this much amount of area, that is the energy, is released from flywheel and its energy is, its speed is decreases. Now what is happening? So here is the next point of intersection. So we have to show this. So next point of intersection is at 180 degree. So at 180 degree here flywheel speed increases because it gaining the energy from the electric motor. So this area we have to show. So area above this load torque, that means energy is gaining the flywheel from the electric motor, and area below load torque means energy is released to the load machine. Now here is also the point of intersection, so we have to show, and here is the area. Then I will show this area. And now this is the point of intersection, and then here is also area that we have to show, and this is also the point of intersection. So if we observe the point of intersection, that the exact values, that is at 0 degree, then at 180 degree, and at 6 degree and 360 degree. Now this point of intersection, that is the exact values, are not known. So we have to find out these values. Now we will calculate crank angle theta for at each point of intersection for this driving torque as well as load torque. So for that we have to show this driving torque is equal to load torque. So we will write here 19,000 plus 7,000 sin 3 theta is equal to 19,000 plus 3,000 sin theta. So this 19,000 and 19,000 is getting cancelled. So sin 3 theta by sin theta is equal to 3 by 7. So we will simplify this. Sin 3 theta we can write in other way, 3 sin theta minus 4 sin cube theta divided by sin theta is equal to 3 by 7. So this sin theta is getting cancelled, and this sin cube theta and sin theta is getting cancelled. So here 3 minus 4 sin square theta is equal to 3 by 7. Now we will simplify this. We will take this minus term or negative term to the right side and this term to the left hand side. So when we simplify this, 4 sin square theta is equal to 18 by 7. Therefore sin square theta is equal to 18 by 28, which is equal to 0.64. Now we will take square root on both the sides. So sin theta is equal to 0.80. Now how to calculate theta? So theta is equal to sin inverse of 0.80, and which is equal to 53.3 degree. So this point of intersection is 53.3 degree. So I will indicate here 53.3 degree. Now if we observe at the crank angle theta, here is the point of intersection, that is this 2 points lies on, that is the torque of driving torque and load torque are at the same point at crank angle 0 degree, and after that it is plus 53.3 degree. Now if we move to the next point, that is at this point, here we can say that at 180 degree also here is the point of intersection. So this is from the diagram. So this point is before 180 degree. So if I take 180 minus 53.3, then we will get the angle 126.6. So I will write here this angle is 126.6 degree. Now again we will move to the next. Then after 180 degree, here is one point of intersection. So if I add 180 plus 53.3, that is I will get 233.3. So this angle, that is 233.3 degree. So by graphical method also we can select these angles, because we have drawn this graph with the help of scale. So here after that, if we observe here at 360 degree, this is the point of intersection, and this angle is before 360 degree. So if I calculate 360 minus 53.3, then I will get 306.7. So this angle is 306.7 degree. Now we will calculate maximum fluctuation of energy in the flywheel. Now if we observe this diagram, here the maximum gap is seen at 90 degree, and here the maximum gap in between the torques, that is driving torque and load torque, is seen at 270 degree also. So we have for the calculated value, when theta is equal to 90 degree, TO is 12,000, TE is 22,000. that is the difference is equal to 10,000. And when at 270 degree, if we take this TO 26,000 and TE is 16,000, so difference is also equal to 10,000. That means we can refer any one area. So we can refer either this area that is below this load torque, or we can refer this area that is above the load torque. So we will refer this first area which is in between the angles 53.3 and 126.6. That means we have to consider the limits for the angle 53.3 degree and 126.6 degree. Now for this curve, equation is given. For the load torque TO, equation is given, and for this load torque driving torque T, that is for this curve also equation is given. So we will solve these two equations and we will take the limits to find out the area, that is I have highlighted with the help of red marker. So how to apply this? So delta E max is equal to limit or integration from theta A to theta B, that is 53.3 to 126.6, and we have to take difference Ti minus To, or we can say here Te we have taken here in question, Te is given. So Te minus To d theta. So what is this Te? So Te is mentioned 19,000 plus 7,000 sin 3 theta, minus in the next bracket we have to consider this equation 19,000 plus 3,000 sin theta d theta. Now we will solve this. So we will take the limit, that is integration of 53.3 to 126.6. So here 19,000 is getting cancelled because here minus sign is there. So 7,000 sin 3 theta minus 3,000 sin theta d theta. Now we will take this integration. So here is sin 3 theta. So what is the integration for this? So it is minus cos 3 theta by 3. And we will give the limits 53.3 and 126.6. Now we will move to the second term. So here is minus sign, we will take as it is. So minus 3,000 and sin theta means minus cos theta. So for minus cos theta we will give limit 53.3 to 126.6. Now this minus and 3 is constant, so we will take outside the bracket. So here minus 7,000 by 3, inside the bracket cos of 3 theta, and here 126.6 and 53.3. So first we have to calculate 126.6 into 3. So I will take 126.6 multiplied by 3, that is 379.8. Now cos of this is 0.940. So here we have to take this value, that is 0.9391. Then we will take next angle 53.3. So again for 53.3 multiplied by 3, because here 3 theta is there, and that is 159.9. So cos of 159.9, that is having minus answer. So here we have to take the difference of the values. So for the first value we have to take then minus sign, and for this if we put 53.3 then we get the answer in negative minus 0.9391. So we have to take here the extra curly bracket and we will complete this bracket. Now in the same way here minus sign is constant, so we will take outside the bracket. So this minus will become plus. So here plus 3,000. And now cos of theta, that is cos of 126. So if we calculate cos of 126.6, that is having minus 0.5976. So we have to take inside the bracket, and then cos of 53.3. So cos of 53.3, that is 0.5976. So here we have to take plus cos of, that is plus sign. Now we have to solve this. So when we solve this, then we will get the answer.